Okay, so welcome back, and now we're going to do rule number 1, and this is going to be the properties of summation symbols. So these are the properties that you can apply to summations. Okay, so it says let A1, A2 through AN and B1, B2 through BN represent two sequences of terms. And let C be a constant. The following properties hold for all positive integers n and m, with m and n both being positive, right? Positive integers, and with m being less than or equal to n. Okay, so what are these properties? Here it says for any sum of a constant, since the constant is not dependent on the index, you basically just keep adding c over and over again. How many times? N times. So you get n times c. Rule number 2, or property number 2, says that hey, if I have a c plus terms of a sequence, right? A1 through AN, then if I want to sum all of these up, then I can factor out the c, right? Because it's just a sum of terms where they have a common factor of c. So I can pull out the c, right, out of the sum, and it becomes the constant times the sum of the terms. Okay? 3 and 4 are basically saying, hey, the sum of the sum of two sequences. So if I take the summation of the sum, okay, I can distribute the sigma across the sum. So if I take the sum of this is equal to the sum of the individual summations. Okay? And then the same thing with differences. I can do the same thing with differences. So the summation can be distributed across subtraction. And then number 5 is saying that I can take a summation and I can break it up into two different sums, where I can take the sum of the first m terms, and then I can take the sum of the next n minus m, right? So the next n minus m terms, and add those two summations together and get the same thing. Okay, so that's just telling me I can break up a summation into different pieces. I can break it up into 3 pieces, right? Because we're just dealing with sums, right? And that's it. So we'll do some proofs to show you that these work, and then we'll go on. Have a great day.